Now we talk about another CNN named ResNet, designed in 2016. The fundamental paper of ResNet is here. The original idea is to improve optimization, which can be difficult for deep neural networks. This is done by adding simple paths in the network so that the gradient flow does not vanish in the backpropagation step. The connections that are added are simply additions between the output of a layer and the input of a previous layer. Therefore, no extra parameter is required. The gradient flow can now take two different paths, one that goes through the classic convolutional layer and one that bypasses these layers. Since the connection is simply an addition, the gradient is not decreased when passing through this connection, therefore preventing the vanishing gradient effect. This type of connections is called shortcut connections. The idea of shortcut connection is not new. It was an early practice for training multi-layer perceptrons to add a linear layer between the inputs and the outputs. Few intermediate classifiers can also be added in some layers of the network, as we've seen in GoogleNet, in order to ease the optimization. There are also highway networks that have shortcut connections with gating functions which are data dependent and have parameters. This creates more complex and flexible networks. ResNet is inspired from VGGNet. It follows some general rules. First, the same number of filters is used for layers that output a given feature map size. Secondly, if the feature map size is halved, then the number of filters is doubled to preserve the complexity per layer. The specific operation performed in ResNet is the addition, that is computing an output y equal to a function of x, the input of some previous layer, and wi, the weights in the corresponding previous layer, plus x. This is the operation we have described before, the one performed by shortcut connections. We may encounter a size dimension problem. There are two solutions for that. Identity mapping is coupled with zero padding to match dimensions, or projection shortcut is used to match dimensions via one-by-one filters. Another comment is that when the shortcut connections go across feature maps of different sizes, they are performed with a stride of 2. These technical details allow to perform additions of feature maps of different sizes. Here is the general architecture of ResNet, which is a bit difficult to read. Here is a zoom. The first architecture on the left is that of VGG19. This architecture of ResNet is depicted on the right, where shortcut connections have been added. The optimization procedure follows the initialization of A et al. That we have seen in the first session. Biases are set to 0. Stochastic gradient descent with momentum is used with a batch size 256, and the learning rate is set to the same value for all layers. The learning rate is initialized with 0.1 and divided by 10 when the validation error stops improving. The training lasts 120 epochs. Batch normalization is also used after each convolution and before activations, and no dropout is used in the network. Here are the performance of ResNet. As you can see, it improves over VGG and over GoogleNet. As for GoogleNet, you have no fully connected layers at the end of the network.